Hey class, today's aim is let's try transformations with coordinates. All right, so actually we've already gone over this, so this will be review. But in preparation for our test next week, it has been a while since we've done some of this stuff, so I want to make sure that this will be a good opportunity for us to review some stuff. All right, so the name of the lesson is rigid transformations in the plane. So if you remember what rigid transformations mean, rigid transformations are also known as isometric transformations or rigid motions. All right, and those are transformations where the pre-image is congruent to the image. All right, so that means I could have a reflection, a rotation, or a translation, not a dilation. Right? Dilations have similar shapes between the image and pre-image, not congruent, unless of course your scale factor is 1 or -1, and then the image and pre-image would be congruent, but those are very specific cases, so we do not refer to dilations as rigid transformations. All right, so number 1 is actually a bit of a review. How far is point A from point B? Well, since it's on a diagonal, I can't actually count how many boxes over it is. So what I'm going to do is I'm going to make a right triangle. All right, just like you would really if you're calculating slope, it's a very similar idea. All right, so I see that if I look at this side of the triangle, that's 3 units. All right, and this side is 4. All right, if we remember from our unit on trigonometry and right triangles, the way that we find the missing side of a right triangle, if we only have 2 sides, is Pythagorean theorem. So I know this is the right angle here, so C has to be my hypotenuse because it's opposite from that right angle. So if I use my formula, a squared plus b squared equals c squared, I just plug in 3 and 4 since those are the legs of my right triangle. All right, 3 squared is equal to 9, 4 squared is equal to 16, c squared stays the same. I'm going to move my steps over here. 9 plus 16 is 25, and that's equal to c squared. All right, and now to get c alone, the opposite of squaring something is to square root it. All right, so technically, the square root of 25 is positive or -5, because positive 5 times positive 5 is 25, and -5 times -5 is 25. However, since we're talking about a length, lengths can't be negative, right? You can't say I am -6 feet tall. It doesn't really make any sense. So we only say that 5 is equal to c. We reject the negative answer. All right, what transformations will take point A to point B? Well, I'll start off with the easiest one. And that's actually, I think, why they wanted you to make this right triangle to find the distance. We see that we went down 3 and to the right 4. So the easiest one I can think of is a translation of 3 units in the x direction. And I'm sorry, I almost made a mistake. We remember that x comes before y in the alphabet, so we always need to make x our first direction. So really, we're going 4 units in the x direction and -3 in the y. So that translation would be +4 in the x direction, -3 in the y direction. Or you could also express that as x plus 4, y minus 3. All right, and there are actually a multitude of transformations we could do here. I could find the midpoint between A and B. That looks like it would probably be a fraction though, but I could use that point and I could say that's my center of rotation of 180 degrees. But that would be a lot of work. What would be a little bit easier is if I said, oh, I'm going to reflect point A over this line right here. Let me do that in purple pen so it's really obvious. So let's say right here, right? I'm going to make this line All right, it hits the x-axis at -1, so that's a reflection. I'm trying to do a reflection over that line, x equals -1. So that's one method. Let me do the second method here. Reflection over the line, x is equal to -1. All right, and that would bring A, if it's 2 units this way, oh, sorry, let me bring it down. If it's 2 units to get to the line, I'm going to go another 2 units in this direction. All right, that'll bring me to A prime. Okay, and then if I want to do another reflection, I could just translate it down, but if we want to stick with reflections, I could find really the middle between A prime and B is going to be at 3.5, right, that line like that. Let me use a straight edge. Practice what I preach. And that would be a reflection over the line y equals 3.5. All right. Okay, so I mean, if you found another way, please feel free to share it. But that is that's all I saw right away for 1.1.